Hey everybody, this is a video that's going to answer an email I get quite a bit, and it's about how do I size the motor to the type of aircraft I'm wanting to fly. And the reason I haven't done a really in-depth video on this is because this is only my experience. I don't want to create a lot of conversation out there about what's right or wrong. I just want to talk about what's worked for me. And I really want to dive into how I figured this all out, okay? So what I'm going to try to do here, and this might take 15, 20, 30 minutes, so I hope you're along for the ride. There's certain things you need to think about in your airplane is how fast is your airplane, what's your targeted speed you want your plane to fly at? So if you know what your cubed wing loading is and you have flown model airplanes and stuck a GPS in the airplane, you're going to find out that most of our airplanes fly pretty comfortably between 25 and 50 miles an hour, unless it's a warbird. Some warbirds literally flat out can go 100, 150 mile an hour at full throttle. Well, that's not the minimum power or the targeted cruise speed. That's somebody trying to do a speed run. So let's just talk about if we were building like a Cessna 172 or building a cargo plane like I'm building right now. Just something that, or even a Piper Cub. Okay, so let's think about the way an electrical motor power system works on our airplanes. What a lot of people don't think about, or maybe they just don't understand and they don't know, is that the pitch of the propeller has an awful lot to do with how your airplane is going to perform. Now, I know that sounds very simplistic. If you've ever flown glow engines or gas engines, we know that a lower pitch prop gives us more thrust. Okay, a higher pitch prop gives us more speed. But because the internal combustion engines, so if this was, let's say, your idle speed, and this was your maximum achievable RPM, a lot of time you would see the power range go like this. So down here, you're not producing a lot of power with that glow engine. But as the RPM start to increase, you really start to see your peak RPM at a certain given point. And let's just say that's 10,000 RPM on a glow engine. Okay? The reason you size your prop is to get to that 10,000 RPM to find what your targeted speed was. If you want to go really, really fast, you want as much RPM with as high as pitch as you can get. But what happens when you're at this cruise speed down here? You've got a really high pitch and you don't have enough RPM turning there, you may not have enough airspeed. So if you go online and find a pitch speed calculator, and these are readily available on the internet. So what I'm going to do here is I'm going to put in that if I had 10,000 RPM and I had a 10 pitch prop, the maximum theoretical mile per hour is 94.7. So if we're at 10,000 RPM with a 10 pitch, okay, and if you remember the pitch, this is your spinner. If the propeller was like that, that's a 0 pitch, okay? But the moment you start to increase this, a 10 pitch means that for one revolution, you're going to move 10 inches. Okay, you got a 10 pitch. Your maximum theoretical speed is 94.7 7. Okay? Now, what you need to remember is, from my testing and a lot of things I've read on the internet, you really are only going to achieve 80% of that with your model airplane because of drag, the airframe being pulled through the air, the efficiency of the propeller blade. So really you're only going to get 80% of that 94 miles an hour is going to be your maximum speed. Now, if you can maintain that 10,000 RPM and you went to a 12 pitch, you're now at 113.64 miles an hour. Okay? So, right now we are only speaking about a glow engine. Okay? We know that we've got this power range, but if you were at half RPM, hang on a minute, let's calculate that for a minute. If you're at half the RPM, so let's say I'm only at 5,000 RPM, my prop speed is 56 miles an hour. So is 56 good for cruising? It might be, but you have enough horsepower out of the glow engine at that power range to maintain that 5,000, or is that 5,000 up here somewhere? So we pretty much, what I wanted to do was touch upon the pitch. The pitch is extremely important when it comes to electric models. Now, I know there's going to be a lot of people that's going to say BS on that, and I really don't care. I'm just going by what my personal experience and my personal testing has proven with my planes that have flown extremely successful. So let's talk for a moment about an electric motor. So an electric motor, and let's just say that the throttle band is pretty much linear on an electric motor. So if you look at the amps as they go up with the prop, you do lose a little bit of efficiency at the top because the faster a prop goes, the less efficient it is moving through the air. It takes more oomph. The drag is squared if I remember my math. So when the electric motor goes up, your amperage is linear, but the forces it's taking to turn it at the higher RPM do come much more resistant. It's harder. So what do you do about that? So let's think about that for a minute. So I've got an electric motor, and I'm saying, gosh, how do I size this to my airplane? I don't have any idea what motor to pick, what prop to pick, what speed controller to pick, how many cells of the battery to pick. This electric motor is like voodoo witchcraft to a lot of people. And it was the biggest fear I had 12 years ago when I got into electric. Now, to be really transparent and clear here, it was 21 years ago or 22 years ago, I built my first electric plane using basically an RC car speed controller. They were all in-runner brushed motors, a C-130 with canned motors, and it flew great, but it was just experimenting back then. But when I got into true electric in this age, okay, the 21st century, it was about 12 or 13 years ago. It might have been a little bit longer than that. It's hard for me to remember how long I've been doing electric. But I was so scared of it because there was nobody out there explaining how do I know what size of motor, what size of prop, what size of speed controller, and what size of battery to put on it. So the way I start with this now, with all my experience I've gotten from this, is I start with how big is my airplane? Okay? So let's say I've got an airplane. Looking down on it, okay, not a great artist right now. Well, I'm a pretty good artist. I'm just not taking much time. I got to put a motor on the front of this that's going to make it fly, right? So what I've got to do is I need to know a couple of things about this airplane is, what does it weigh? So just for this example, I'm going to use my MSL2. Okay, my MSL2 weighed 59 pounds. Okay, had 100 and I forgot. I think it was 188 inches. 188 inch wingspan. The cubed wing loading was basically under a sport plane, but just above a glider. So I knew my targeted airspeed, believe it or not, for this airplane was going to be between 35 and 50 miles an hour. Okay? So those were the parameters I was starting with, 59 pounds. So I knew that I probably wanted around 100 to 110 watts per pound. And the way it ended up, once I kind of did my reverse math, was I would take, hang on a minute, I want to do this factually for you guys. So I would take my 59, and I was going to take it times, let's say 105 watts a pound. So that told me I needed around 6,195 watts. Okay, so I was going to need 6,195 watts. Okay, so I would go online and find me a motor. I happen to already own a Hacker A100, which is 150 kV, and it's basically a 7,000 watt max motor. Okay, so I knew I had a motor that could carry enough watts. So now I needed to say, okay, how am I going to prop it? How am I going to make sure I'm in that 35 to 50 mile an hour zone? So what I do is I basically go to my prop speed calculator and say, you know, how many RPM do I need? And I'm going to start off with a 10 pitch prop here, everybody. Okay? And I'm going to explain to you why low pitch props on electric, in my personal experience, is wrong. Okay? So let's say I can turn 5,500 RPM, and my prop speed is 52 miles an hour. Now 52 sounds, hey, 35 to 50, but keep in mind, you're only going to achieve about 80% of that 52 miles an hour. So 52 is not fast enough. I've learned through my experience, I want around 75 miles an hour of air coming off the props. Okay? So how do I get there? Well, I need to look at a higher pitch prop. So if I go to a 14 pitch prop at 5,500 RPM, I'm at 72 mile an hour. Now we're getting closer. Okay, now we're getting much closer. Now, you do need to set up a test rig, put your motor on it, put your prop on it, put your electronic speed controller on it, and on this setup, I found out that 6,100 watts equaled about 160 amps on my speed controller, and I have a 160 amp speed controller. Now, as a little bit of a caveat there, I normally will stay 20% under my electronic speed control's max amps. However, this Castle Ice 160 heli guys use them up to 180, 185 amps and have never blown it up. So I feel comfortable going to 160 amps on my speed controller. So at 160 amps. Now, I did do one bench test where I got 170 amps. Well, that was too much. So how did I bring that down? I dropped one cell. I went from being 11S to 10S. Now, did I lose any RPM? Well, at the 170 amps, I was at about 6,300 RPM. I'm sorry, I was at about 5,800 RPM, which was about 6,300 watts. Okay? So as you increase your pitch, you're loading the motor, which will increase the amps. But here's the reason you want a high pitch prop. And I know some of you are going to say I'm full of crap here. And all I'm going to do is say, build the airplanes I build, do the testing I do, stick a GPS in the airplane to know what your true speed is. Use a Castle Ice controller with telemetry so I know exactly what my amps in the air were and what the loads were on my motor, and then tell me I'm wrong. Because everything I've tested is where I've gotten my results from. Okay? So the reason I wanted a higher pitch prop is that, yes, I am pulling a boatload of amps at full throttle, and I'm getting about 72 miles an hour out of my prop speed, my prop pitch speed, okay? Prop pitch speed, okay? My targeted speed was 35 to 50 mile an hour. 80% of that puts me in there. The reason I want that high pitch prop is because electric is linear. As I bring my RPM down to about 60%, I still have enough prop speed to keep me in my cruise speed of the airplane. Now, if you got a real draggy biplane, some people will say go to a lower pitch prop. Not in electrics. The faster a propeller spins, the less efficient it is. The more drag is squared. So the slower you can turn that prop and have the prop speed you need, which means increasing the pitch and hit your amp target, you will find the sweet spot of that airplane. Okay? My MSL1 had essentially 85 watts a pound. Many people said it would never fly. I actually had one guy tell me that his wife knew more about electrics than me, and that if the plane would not, it'd be a dud, it wouldn't fly. The MSL1, which was my vintage-looking airplane with all the aircraft cables, the draggiest airplane I ever made, flew over 600 flights without a single crash. It did have one off-field landing because I had bad batteries. And if you were at CEF 4 years ago, you saw a miracle where it landed in between farm equipment and didn't break anything except bent the landing gear axle. But, and that's one reason you shouldn't put 500 flights on batteries, okay? or 340 flights on the batteries. But I'll talk about batteries later, not today. But the MSL1 flew at 155 amps, which was about 5,700 watts or 5,600 watts, something like that, with a 14-pitch prop, 30-inch diameter, and it was turning about 54 or 5,200 RPM, and the plane flew absolutely beautiful at around 85 watts a pound. The plane weighed 74 pounds or 73 pounds. So it flew perfect. Now my MSL2, which is my vintage racing looking airplane, this is what this math is. 59 pounds, 188 wingspan, pulls about 6,200 watts at 160 amps. The prop speed on it was around 72. The plane flies between 35 and 50. Now, the RPMs and everything, I do have a little bit of a question about this 80% here, because my GPS shows me in level flight at full throttle going almost 70 miles an hour. And if this prop pitch speed is really 72 point something mile per hour, I don't think that my math is really working me. I don't think the prop is that efficient. I've always been told, and even in my earlier testing, even on my small park flyer stuff, you only see 80, maybe 85% of that prop speed out of your airplane's actual airspeed. Okay? So the way you size, I'm going to start at the very beginning real quick. The way that I have been sizing my motor is figure out what airspeed does the airplane need. Okay? Figure out your wing loading. Okay? What is your cubed wing loading? If you're in between a glider and a sport flyer, you're not going to need a lot of airspeed to fly that airplane because the wing loading is so light. However, if you're a warbird with a really, really heavy wing load, you may want a prop speed of 90 to 100 mile an hour because that airplane on a final approach might be in the 40 mile an hour range. It might cruise at 70. And if you want an airplane that's going to go 150 mile an hour, you're going to want a prop speed of like, my God, probably, well, hang on, let's figure it out. If you were to, that's an interesting question. So let's say for shits and grins here, that I got 10,000 RPM. No, they don't go that fast. Let's say you got, I think 8,500 RPM is about the maximum. I heard some of the guys doing electrics. And you can find some 16-pitch props out there, but they're very, very, very hard to find. Yeah, see, that's 130 miles an hour at 8,500 RPM. So I'm guessing they're coming out of dives when they're going 150 mile an hour. That's not level flight. We got to also keep that in mind. Hang on. So if I had a 16 pitch at 10,000 RPM, yeah, I'm going to be going 151 mile an hour prop speed, which will put you in about 130 mile an hour range. So you need to think about your airspeed, your wing loading, and then you take from the true weight of the plane, and then you look at your watts per pound. And if you're an aerobatic airplane, the more watts the better. 150 to 200 watts a pound is great. If you're flying the stuff I fly, I'm in the 100 to 120 watt range. If you're flying my vintage airplanes, I was at 85 watts a pound. This cargo airplane, when it is fully loaded at 100 pounds, will be about 108 watts a pound because I got 10,200 watts out of the 4 motors. Okay? But with it empty at 75 pounds, it's going to be like 130 or 135 watts a pound. So the plane's going to perform awesome empty. So when you're sizing the motor, you really want to know what's the weight of my plane, what kind of flying do I want to do, put the highest pitch prop you can on it, and then control your cell count until you're hitting the sweet spot of that electronic speed controller. So think about that. You want your pitch. You want the cell count to equal the amps you want, okay, or watts. But you don't want to over amp your speed controller. So think about that. If I've got a 14 pitch, it takes 10 cells in series to hit my targeted amps. You're going to be good to go. But keep in mind, the higher the pitch, when you bring the throttle curve down, you still have a high pitch at the mid. You still have a high pitch giving you good, decent airspeed at 1/2 and 3/4 power. Getting a low pitch prop, the moment you throttle it back, you may not have enough forward airspeed to fly the airplane. So that's the reason some people are like, man, I'm flying the airplane at 3/4 or almost full throttle the whole flight, and it just feels like it doesn't have enough power. Well, what's the amps on your speed controller? If you've got a 100 amp speed controller and you're only at 80 amps, add the pitch of that prop. Get that plane moving faster. Okay? I know people that fly 100 amp speed controllers at 60 amps because they're afraid of blowing them up. If you know and can track that you're flying it at 90 amps and it blows up, send it back to the manufacturer and tell them to pound salt. You want your money back. You got a shitty speed controller. A 100 amp speed controller should be able to run at 100 amps every day that you own it. So get the amps up to the maximum of your speed controller, get the pitch up as high as you can, and you're going to have success. And all of my airplanes, I put the highest pitch props I can buy on them, and then put it on a watt meter and check the amps to make sure I'm not overamping the speed controller. Okay, now if you're buying a park flyer, which I've modified every airplane I've ever bought, I put the highest pitch prop I can on the plane, and then I go out, and if I'm overamping the speed controller, I just go up a little bit in the speed controller. There is one last thing you need to know, though, if you're modifying an airplane to a high pitch prop. Your plane is going to go faster, okay, unless you bring down the cell count, okay? So you got to worry about fluttering airplanes. I had the horizontal stabilizer on my Park Zone Corsair flutter a little bit one time, and just because I got the thing going ridiculously fast with a high pitch prop, and I didn't change the cell count, and then I just increased the speed controller side. But keep in mind, when you increase that prop pitch, your amps will go up, so you may have to decrease cell count. Okay, now some people are going to go, well, wait a minute. Everybody flies at 12S. Well, yeah, because you're going to size your prop to not over exceed your speed controller at 12S. 12S is nice because you've got so much voltage that when you throttle back, you do fly longer. Okay, the higher the voltage and the less amps you're using, you fly longer. You use less milliamps. But think about this. Let's say you got a 12S with a flat pitch prop. You're spinning that thing so stupid fast it's inefficient, and you're wondering, wow, I got a 12S plane. Why isn't this thing flying any better? Check your amps. If you got a 12S setup and you're only getting 110 amps out of a 160 amp speed controller, increase that prop pitch. It'll change the way the plane flies completely. last disclaimer, and I'm telling you this and I'm warning you this, if you just go out with your setup right now and put a real high pitch prop on it and don't put a watt meter and look at the amps, you can burn up your speed controller. Okay, your system might be designed right now in a very inefficient way. You may have a real low pitch prop that some manufacturer put on the airplane. They did their test. You're at the max of that speed controller. So when you go and add a higher pitch prop, you might blow up your speed controller. So be very cautious what you're doing here. Now, higher pitch props, for me, has made complete difference in the way that I power my airplanes. If I could buy 16 pitch props, I would. I made 6-bladed 16 pitch props and tested them out of carbon fiber, and they were awesome, except they were a horrible bitch to make. The man hours and labor and just the precise bullshit time it took to make them work killed me. Another thing to think about, though, is how many blades do you need? And this confuses people all the time. The reason large, like warbirds, had multi-blade propellers is because they needed enough prop to grab enough air for the horsepower that was in that big radial or that big V12. Okay? So instead of making the landing gear longer and putting a bigger diameter prop on there, they added blades. So the only reason they added blades was to be able to grab more air with the available horsepower, and they didn't want to lengthen the landing gear. That's the reason you see some planes with 3, 4, 5 blade props, because they've got to grab whatever air they can with the horsepower that's available. On electrics, it's a little bit different. Okay? You want to turn the prop the slowest RPM possible, pulling the airspeed you need through it, because the props are more efficient at lower speeds, because you know drag is squared. The most efficient propeller is a one-bladed prop with a counterweight on it. And they're out there. Look, Google it, one-bladed prop. Because it didn't create any turbulence that it was going, there were less turbulence that the blades were following through as it went through the air. For me, I love 3-bladed props because of the look, not their efficiency, but they're 14 pitch. The nice thing about a 14-inch 3-bladed prop is it's pretty much moving the same amount of air at 21 inches as a 28 or a 29-inch propeller. So I've got smaller diameter. But if I want true total efficiency, I would have a very large 2-bladed prop with the highest pitch I could put on it. But me, I like the look of a 3-bladed prop, especially on a cargo plane. So, last disclaimer. There could be some aeronautical engineer, propeller design expert, physicist, gynecologist. There could be somebody out there watching this and saying, Damon, you're full of shit. None of this is right. I don't care, because it works on my airplanes, and my airplanes fly fabulously. And I get long flights, and I'm not burning up controllers, and I'm getting great performance. Okay? So I'm just saying that consider what I'm telling you here. See if it applies to what you're doing and if it helps you. Okay? So the only reason I do these videos is to try to make you all successful. That's the only reason I make these videos. Okay? Because I have so many fans and followers say, how do you do that and how does it work? I'm sharing how I have done it. That's all I'm doing. I'm not saying I'm right, because I have no schooling, no math. Well, I do have some aeronautical engineering friends that always tell me I'm spot on right. It does make me feel good. But, disclaimer, don't blow your shit up. Don't blow stuff up, guys and girls. Don't just arbitrarily put a high-pitched prop on your setup without knowing what you've increased your amps to. Okay? So thanks for watching these videos. I hope they're informative. I get a lot of emails about this power setup. And I'm probably going to do another video probably this fall where I'm going to get my test rig out where I test the thrust. Because one thing I'm still wrapping my head around is the ungod amount of thrust that we get out of these electric motors because of this linear power curve. If you want to cruise here, you got to look at what your prop pitch speed is going to be. And is this 40% power giving you the airspeed at 80% to fly your airplane at cruise? I always try to set my systems up so that 40%, that's where I cruise at. The MSL1 had to be at 60% because it was so draggy. The MSL2 will fly all day at 40% at about 38 miles an hour, and it's beautiful. And the last thing I'll talk about is how big milliamp batteries you have. Milliamp size batteries have gotten huge, and you can put them in parallel. So if you have a 5,000 milliamp pack and you fly your plane, you get a 4-minute flight, put that in parallel with another 5,000 pack, and you're going to double your flight time. And that's how I get long flights on my airplanes. Now, if you can truly do the maximum cell count that your speed controller can handle, get that voltage up, you will extend your flights because you're flying at a lower throttle setting. So max your speed controller. As long as you know it will, how do I say this, everybody? Every speed controller I've got, I max. If it's 100 amps, I max it. If it's 160, I max it. If it's a 60, I max it. Now my Jetty 77s, I max them all the time at 77 amps. But where I normally fly those are 20% less because of paranoia. And I probably shouldn't do that, but I've got so much power on this transport plane, I really don't need to max those. Well, and also, another thing you have to remember, one last thing, everybody, is your motor. What is it rated at for watts? Okay? Do not overwatt your motor. The nice thing about hackers are, they overbuilt them so much that you can get some of the hacker motors so hot you can fry an egg on them and you're not hurting the motor. The A60-16L, I talked to one of the people that developed that, he said they would have them so hot that you couldn't touch them. Mine are never that hot. And I think they're made for 2,800 watts for 15 seconds. I run them all the time at 2,500 watts for like 8-minute runs, and I can put my hand on that motor, and it is still, it's hot, but it's not so hot you can't touch it. So hopefully this helps you all. Keep the emails coming. Keep in mind, big disclaimer here, this is what works for me. Okay? It should work for you. But don't blow your shit up. Rock on, everybody. Have an awesome day.